My name's Ian Land, and I lead Aerospace and Defense Marketing at Synopsys. I'm here today with Kenneth Larsen from the Synopsys 3D-IC team and Marc Swinnen from Ansys. Today, we plan to talk about multi-physics aware 3D package design for aerospace and defense applications. The US government has recognized the importance of 3D-IC with programs like the RAMP program from DoD, as well as DARPA's ERI 2.0 program. Let's go ahead and get right into the questions. My first question is for Marc. Marc, what is SWaP? Why is it important? And why is it becoming so urgent in modern system design?
Yes, Ian. So SWaP, they have been important considerations for aerospace and defense systems for decades. It's with each successive semiconductor node and generation, the complexity of the chips increases substantially, and often the space they have to decreases, the space available for these systems. So especially in challenging environments like those at sea, in the desert, or in space. And the increasing integration density has been a huge benefit for realizing more capable and more portable systems, but it's also raised some serious multi-physics challenges. So the famous Moore's law is key to increasing digital logic density on silicon. But a complete system involves more than just the silicon. There's lots of interactions among many different physical mechanisms, and they intensify as you pack things closer together into more tighter and smaller systems. And so those are some of the issues that you have to deal with in these modern, really high SWaP devices.
Okay, very good. Thank you, Marc. All right, the second question I thought I would ask Kenneth is, why is 3D heterogeneous integration so important to SWaP and hence to the aerospace and defense markets?
So with the 3D heterogeneous integration, it's possible to take an entire high-performance computing rack, for example, and shrink it from a big board or a big system down to a small package that easily fits in a backpack, nose cone of a jet fighter, or perhaps someday implanted in the bodies. It has been more than 55 years ago since Moore's law came into being. We know that the geometric size of components of chips, the individual parts of the chips, cannot be reduced without a limit, meaning that one day the number of transistors that can be integrated into a chip will reach the limit. We are not yet at that limit, but each technology shrinks take longer and at an enormous cost. So from a cost perspective, splitting up large chips into smaller chiplets, optimizing each chiplets in the most suitable technologies and also materials, and combining them into a small semiconductor package is advantageous. Smaller chips tend to yield better. Chiplets can be reused in different applications. And with 3D heterogeneous integration, the various chiplets can be stacked on top of each other, creating new possibilities in aero and defense designs.
All right, the next question we're actually going to ask both first Kenneth and then Marc. And so the question is, what are the key challenges that new 3D-IC solutions must address?
There are multiple concerns for 3D HI or 3D heterogeneous integrated solutions that need to be addressed. In summary, they need to address the computing performance and heat dissipation per unit volume, the latency and bandwidth of the interconnect, the environmental concerns, including power dissipation in extreme environments, and also application-specific capabilities and concerns like security and also safety. Regarding compute volume, 3D packages have significant advantages over traditional 2.5D and 2D designs due to the stacking using direct bonding techniques and through silicon via approaches, enabling high bandwidth, ultra short latency, and incredible power efficiency bit transfers due to the proximity of the chiplets very close to each other or on top of each other. Synopsys tools are unique because they can do multi-chip and package design together, along with system and chiplet sign-off analysis. This is unlike legacy EDA solutions that starts from the PCB rim.
Thank you, Kenneth. So yes, environmental and thermal concerns are key challenges for our A&D customers who have these high-performance semiconductor systems in very compact form factors. That they need to dissipate heat in very challenging environments, deserts or in space. And the joint Synopsys Ansys solution addresses thermal management all the way from chip through package through full system. So it's a complete comprehensive thermal management system. This also includes access to multi-physics solvers like fluid dynamic simulation, which is really important to establish the impact of fans and heat sinks. So that has to be part of the package. And mechanical solvers to predict thermomechanical stresses and warpage of these multi-die packages. So all these solvers are also accessible through the system. And with the ultra high speed digital signals in these advanced platforms, so not just RF signals, but also very high speed digital, other physical design considerations like electromagnetic interference and electromagnetic coupling have become absolute must-do analyses. At these speeds and these densities, these really electromagnetism has to be analyzed. And with these joint solutions, customers get at the end a state-of-the-art 2.5D or 3D design, as well as the multi-physics co-simulation of both the chip and the package together, so that these different effects are all taken care of and properly, accurately modeled.
Okay, very good. Thank you, Mark. We're coming up to the last couple of questions here. For Kenneth, why have Ansys and Synopsys teamed for 3D heterogeneous integrated design? And why not just keep the effort separate?
Right. So Synopsys offers a complete chip design and heterogeneous integration platform that's built around the state-of-the-art 3D IC compiler, 2.5D and 3D die-to-die interface, and chiplet IP, and integrations with the Synopsys tools for design synthesis, for verification, and also silicon photonics. So Synopsys teamed with Ansys, which has a strong presence in aerospace and defense, for state-of-the-art environments and multi-physics simulations. So Ansys add environmental simulations for a broader envelope in several domains, as well as quick optimization and retargeting for derivative products.
Excellent, thank you. All right, we're down to the last questions. Mark, any final comments?
Tackling these complex design challenges facing aerospace and defense community requires, a combination of a really broad array of tools and capabilities and analyses. Things are not getting simpler with time. And all of these tools have to work through a proven data exchange platform. How do you get all these tools to work together? And Synopsys has done a really excellent job in developing such an integrated platform. For advanced semiconductor design, it also allows us to create a joint solution with golden accuracy solvers, right? So this combination lets you create, the best SWaP device, but that's also robust and reliable in the field, as it's been tested across a wide array of effects and multi-physics simulations. So that's really one of the key elements to handling this complexity, is having that platform.
All right, excellent. And Kenneth, any final comments?
So we're excited and proud to work with the best-in-class environmental and multi-physics simulation provider, Ansys, to provide unique solutions and complete solutions to our customers abroad, many market segments, including A&D. Our joint 3D heterogeneous integration platform will usher a new area in the aerospace and defense semiconductor design and system designs.
Okay, to wrap up, I want to first thank Mark and Kenneth for their time and the insightful discussion today. And then two, I want to thank you, our audience, for your time and consideration and interest in our topics for Synopsys Aerospace and Defense. And finally, I want to invite you to visit synopsys.com/aerospace and defense and sign up for our quarterly A&D newsletter. Thank you again.